Hey everyone, welcome back. Today we are building something interesting, the NetBox Auto Discovery Stack from scratch. So I'll walk you through the entire setup step by step. We'll deploy the DIODE server, integrate the plugin with NetBox, launch the agent container, and finally we'll see the discovery live in action. Now in my previous video, I have covered how these components work together. And if you missed it, I'll drop the link in the description and it will give you helpful context for today's build. Alright, this is a complete walkthrough, so grab a coffee, let's dive right in. Alright, the NetBox discovery system consists of three major components and we are going to run all the services in a single host for this demo. So let's fire up the event G and power on the management switch and the NetBox node we have set up in our previous video. Then SSH to the NetBox node via VS Codes once it is booted. So as a quick check, let's make sure that we have the Docker Compose version 2 installed. Now let's create a clean directory structure. So I'm creating a main folder called NetBox Discovery with the two subdirectories, one for the DIODE and another for the ORB Agent. So let's cd into the DIODE folder and download the quick start script for the NetBox lab. So once downloaded, we'll make it executable and run it with the NetBox URL. So these scripts automate the entire DIODE setup. It downloads all the configuration file, create the folder structure and set up OAuth credentials. So the most important part here is the client credential stored in the JSON file under the OAuth/client path. So we'll come back on this in a moment. Now let's bring up the DIODE server using the Docker Compose. This will download few Docker images. So the DIODE runs a couple of microservices in the backend. So let's quickly talk about three important ones here. The first one is Hydra, which is the OAuth 2 server, handles all the authentications. Then comes to the DIODE ingester, which is a landing zone that receives the data from the agent. And third service is the DIODE reconciler, which pushes the processed data to the NetBox. So I won't deep dive into the theory in this video, but understanding these components is crucial for troubleshooting authentication issues. So while DIODE is building up, let's move to the next step where we'll see how to install the NetBox plugin. So let's navigate to our NetBox Docker directory, the same one which we created during the NetBox installation, and verify the NetBox is already running and healthy. Now comes to the tricky part, installing the plugins. So the pre-built NetBox image doesn't include the custom plugins by default. So we need to install it manually and commit to the container. The first step is to enter to the NetBox container as a root. Alright, so inside the container, let's install the pip. And we'll also install the NetBox DIODE plugin using pip3. So the plugin is available as Python package on PyPy. Now let's quickly verify the plugin is installed correctly. We can see it in the site package directory. We can also import properly in Python. So let's exit from the container. Now here is a key step. We'll commit this container as a new Docker image. And this makes the plugin permanent and it survives when the container restarts. Alright, now we can see our new custom image listed here. So on the step 3, we'll update the Docker Compose to use our custom image instead of the pre-built one. So let's edit the Docker Compose file and comment out the default image first. And let's add our new custom image and save our configuration. So this is pretty straightforward. So on the next step, we need to configure the DIODE plugin with the OAuth credentials. So let's edit the plugin.py file in the configuration folder. Remember we talked about the client credential on the DIODE server. So we need to use the NetBox to DIODE credentials here. So let's copy that and update the client ID and the secret on the configuration file. Perfect, we have done the plugin configuration. It's time to bring up the NetBox on the new custom image. So the container looks healthy, which indicates the plugin also installed successfully. Awesome. So the final step would be to run the migration to activate the new plugins. So this creates a database table for this plugin. Alright, so migration usually goes quick. So now we can restart the NetBox and the worker node to load the DIODE plugin. Alright, so that's about the diode server installation and the plugin setup. So let's verify this from the NetBox UI. So navigate to the plugin section and we can see a diode in the sidebar. So click on the settings. Here is our configured diode target, right? And there is a client credential tab where we can create credentials for the agents. And right now it is throwing some error about the plugin configurations. And the issue here is that the diode containers run their own Docker network while NetBox run on a separate networks. So they can't communicate until we put them on the same network. The fix is simple. We can add the network configuration to the diode Docker compose file to join NetBox network. So once that is done, everything starts working perfectly. And I'm going to include all the troubleshooting commands in the video description in case you run similar issues. Alright, that covers the NetBox plugin verification and the network connectivity issue. Let's move into the agent setup. So let's cd into the ORB Agent directory we created earlier. So for the agent, we need to set up a configuration file first. So we'll create a file called config.yml, and in this configuration file, we'll define the target host. Since we are running all the services on a single host, it is going to be localhost :8080/diode. This is the termination point for the diode, where it will push all the discovered data. Next comes to the client ID and secret. This will be generated from the NetBox UI. So let's go to NetBox, click Create Credentials, and give a name and click Create. So NetBox will return a client ID and secret. So let's copy this and update on our agent configuration file. Next, we need to specify the device discovery parameters. So in this demo, we'll be discovering all the Cisco routers in our eventual lab. So we'll define the site, tenant, device role, or any other details we want NetBox to populate automatically. Then comes to the individual device config. We specify the driver type, we set iOS here for our lab devices, and provide a device credential for SSH access. Finally, we can set the schedule on how often the agent should run and the target subnet range for the network discovery. So that's pretty much on the configuration file, and you'll find this on my GitHub page for the reference. Next, let's create a Docker compose file for the agent. So we'll use ORB Agent image from the NetBox lab, give a name for the container, and specify the path for the configuration file we just created. So that's the simple Docker container setup for the agent. Now let's go ahead and start our agent. It will take few minutes to download the image and get them ready. Meanwhile, what we can do is we can go to the EVE-NG and start one of the router in our virtual lab. In few minutes later, we can see the agent container has downloaded the image and it is up and healthy now. And we can go back to the NetBox UI and see if it has discovered any device from our lab. So on the NetBox UI, let's go to the devices under the device sections. And there it is, our first router vios-r1 automatically populated into the device table. Excellent, it is marked as active. We can see the device role, manufacturer, and OS type details. And go to the interface section. All the physical and logical interfaces are present and are discovered. And same goes with IP address and prefix. Everything is automatically populated. Very nice. Now let's start other two routers from the EVE-NG and watch the discovery in action. So we'll also enable the logs to see the data flow. First, on the ORB agent logs, ORB is connecting to our routers and sending the data. Now let's check the diode logs. So we can enable the logs on the diode ingester as well as the reconciler. So diode ingester is receiving the data successfully. And if you look at the logs on the reconciler, it is pretty much receiving all the information coming from the device, like prefix range, loopback IPs, model details and all. Excellent, so data is flowing through the entire pipeline. Finally, let's go to the NetBox and check the discovery status of the recent devices. So here we can see two additional routers have populated in NetBox with interface and IP address and all other parameters. So this is a huge time saver. It ensures everything is accurately placed and avoid the lengthy manual process. Alright, that's it for today's video. Hopefully this gives you a solid foundation for setting up NetBox auto discovery in your own lab. Let me know how this works in your setup. Thank you and we'll see you on the next one.